going to start recording. I'm going to do a share. This is population ecology, right? So I wonder what this means, population ecology. Well, some of you already know what a population is. We got that definition down. Now I wonder what the ecology part is. All right, well, so we come here and we're like, wait a minute. So, we see some wolves. Okay, so this chapter, we're looking at a picture, right? Picture speaks 1,000 words, right? You guys live in the world of memes. Pretend this is a meme. What do you guys think of it? What comes to mind? And there's just no right or wrong. Just share your mind. Like, what comes to mind?
Ice Age.
Go ahead. I'm sorry, I didn't.
It kind of reminds me of like the movie Ice Age, or I guess like the actual thing, but.
Okay, yeah. Okay, Ice Age. Any other, things occurring when we see these? Like, it's just a picture. Let's pretend we're walking in a museum. Okay, this is not an exam question. This is not a population ecology question. There's a lesson that I'm going to teach you after you after you try to attempt to share your thoughts.
There's animals.
Okay, great. Right. Now, in these animals, he said animal. So is that singular or plural?
Plural.
Okay, so that means more than one. So when we look at that, these are animals. Okay, so they're hanging out. There's more than one.
They're a pack.
They're a pack. Yeah, they're a pack. Now, within that pack, is there like a dominant male and a dominant female?
Yes, it's called an alpha.
Hey, there's an alpha. So usually there can be an alpha female and an alpha male. And they kind of give the orders and the pack kind of follows, right? They should have two characteristics. Typically they do. They do have good intelligence and as far as computing and tactics and things of that nature and reducing risk. And they should also be kind of fit and brave and strong. Those are some of the characteristics that the alphas should have, right? You can't have a really strong alpha male, alpha female, and be a total dummy head, and then you put the pack at risk with like a few grizzly bears, and then they get all mauled or they get hurt. So you have to think about the risk. There is no doctor to come, fix their broken leg. If they get a broken leg, they're done. It's not like us. We go to the hospital, we get a cast. There is no hospital for them. So the risk, do they try to take down that animal? Is that animal maybe too aggressive? Should they not? That's going to be largely dependent upon the alpha. So that's where intelligence comes into play. What else do we see?
I mean, what is that, like a river?
Yeah, we see some rivers. So animals are always going to stay not too far away from their water source, right? They're not going to stay too far away from the water source. Like, you just can't lick a bunch of snow and think you're going to get hydrated. It doesn't work like that. So there's a water source, so they want to stay near that water. It's not too close to it, right? But they need water, so they can easily come down here. They can come and drink, and they're easily accessible. This is not super dangerous for them. They could do it. Even a human can step on these rocks and get some water. So that's what we look at, right? So the lesson of this is that you're the younger generations, the generation of pictures and selfies. So when you look at a picture in your classes, whether it's history, whether it's any type of literature, whether it's in the biological sciences, look at a picture and just try to take in what's the information, what can we gather from here? And some of the things that you guys said already, like packs and alphas and all that, has a role in what we're going to talk about. So pictures really do speak 1,000 words. I just wanted to stop, take a little pause on that. Now let's take a look at some questions. What is ecology? I asked that already to you just so we can get thinking. If there is the term ecology, you can probably bet there's going to be ecologist, right? What are the different types of population growth? We'll take a look at that. And what factors influence population growth and population size? Ooh, there's a lot of factors there. Now, this here was a study of tracking wolves and moose over many years to understand the dynamic fluctuations between the populations. Okay, and this is taking place. This is taking place in Canada, and they tracked and tracked and tracked over many years. And they want to see how it is a wolf population correlated to a moose population. And one of the things is that when we're younger, I don't know if like high schools still do this, but they say what's it called? The food chain. Well, things are not linear in nature. The food web is way more of an accurate, closer to the truth depiction of what is out there. Many things interacting with many things, and certain things impact certain things, right? I think we learned that with the CAFO example, the concentrated animal feeding operations. Yay, let's just have all the cows just graze. We've got to cut some trees down, right? We're all connected. That's what I've been trying to teach you guys. There's never a perfect solution. There's good solutions, there are better solutions, and there are horrible solutions. And that's what I've been trying to tell you guys, that there's just pros and cons, and you have to outweigh, you have to put it on a balance. If there are more pros, less cons, and so forth. So we learned that, and we're going to be seeing that the balance of life is here as well, and how populations of just only two species are related or impact each other. So let's answer this question. Ecology, I mean, it has to be important because the first word in the chapter is population, and the second one is ecology. So let's take a look at this. The study of interactions among organisms and between organisms and their non-living environment. Whoa, this is a little different than the things we were talking about in our past chapters. Why is it a little different? They bring in the non-living. Before we were all talking about interactions, population dynamics, bottlenecks. We talked about the founder's effects, all these different things, right? But now we're going to get into, wait. You're telling me that there's an interaction between the living, which is among organisms. It should say, the definition I think would be better if it said the study of interactions among same species and between other species and their non-living environment. That would be cool, right? Because the wolf, we just looked back up here, the wolf is a species and the moose is another species. So we could maybe specify that a little better, like within species and outside of other species and their non-living environments. I think that would be good. I'm just telling you that's what it is. So living organisms interacting somehow, some way, and the non-living environment. Like we go back to this picture, some of this non-living environment, some of the non-living, and even this can be a little complicated. So what is the non-living here? Okay, it's going to be the ice because that's H2O, and some of these rocks. But I can guarantee you that somewhere along these rocks, there's living things. So it's a little difficult sometimes to say, what is the non-living? You look at dirt, you're like, oh, that's just non-living. No, it's not. I mean, some of it, yes. The actual soil particles, yes. But there's so much living things within the dirt. Just keep those things in mind. So here are some interesting things. We go from levels. We have an individual of a particular species, okay? Of a particular, let's say human. Let's say human. We have an individual human, then we have a population of humans, then we have a community of humans, and then once we bring in the surrounding environments, both the living and the non-living, you then have an ecosystem. That is not clearly stated here, right? It's not, right? So let's give an example. You go to college, you're an individual, and then you have a college population, right? And then you have that college, and then you have other stores and you have other restaurants around the college or events and maybe movie theaters for students to go. Okay, now we're talking about a community. But then once you start including, well, maybe there's some rivers, some streams, some hills, some rocks, and all these other things around, now you're talking about the ecosystem and other species, birds, squirrels, turtles, whatever. Now you're looking at the ecosystem. So here we go, taking a look up. Pictures again speak 1,000 words. Individual, there's the individual, there's its population. Now in comes community, other thing. You can get another species as well. But in the human example, it would just be a humans, right? Okay, that's the human one, because I was only talking about humans. But in this particular case of biology, interacting populations of different species, right? Community. And the reason it doesn't apply so well with humans is because we don't have that type of interaction with other species. Like we have interactions with our dogs and our cats and our pets, but that's not really a community, right? You have a school board meeting. Do you invite the dog? Do you invite the cat? You know, you have a ferret. Do you invite the ferret to the school board meeting? Do you invite, you have a city council meeting and you guys are talking about, I don't know, where you're going to get your water supply. Are you going to bring the white-tailed deer that's 2 miles away? Are you going to bring that white-tailed deer? Are you going to bring the wild pig? You know, are you going to bring the boar to the wild boar? No, we don't, right? Because we're humans. So it gets a little different there, right? But when we speak of biology, like in a course like this, okay, now the community kind of changes, right? And now we say, okay, the interaction of populations within different species. Like wolves prey on moose, oh my gosh, ticks. They can infest moose. They can infest other animals too. Like here, it's pigs. Moose feed on, okay, yes, they can feed on some trees and also some grasses. So community, interacting populations of different species within a defined habitat or within a boundary, right? It's within a certain area. Ecosystem, all living organisms in an area and the non-living components of the environment in which they interact. Now that's some complicated stuff. The bees, the trees, the ticks, the grasshoppers, the bacteria, and any other mammals, the fish, the minnows, the algae. I mean, it goes on and on and on and on and on. It's extremely complex. And there are much of ecosystem interactions that we do not know. So population ecology. All right. So wolves and moose have different lifestyles. Of course, they have different lifestyles. They're different species. They're going to do different things. Not only that, do they have a different lifestyle, but in the way they walk, in the way they move about, their patterns. Animals have patterns. Humans have patterns. If anything, I think humans are the ones that probably have some of the most common patterns around. Humans are so predictable, sometimes too predictable. You want an example? I'll give you an example, 2 of them. Every semester, before COVID, we had students come into class. In every university I've ever been to, You never tell, I never told students like, like little babies, like you must sit here, like what's your, last name, and we're gonna sit in alphabetical order. Like what the hell? Like no, just sit wherever the heck you want. And notice how how very few of the humans change it up. They come the next day and they sit in the very same spot, same row, same desk. And then when a human decides to change it up and sit in a different place for whatever, they're like, I'm going to sit here. There's another human that stops and looks at them like, that's my chair. That's my chair. Like, or they're like so awkward and they stop and then they look around like, why is he or she in my chair? Like someone help me. What do I do? And they go sit down somewhere else. And they sit down somewhere else. And the other person who was supposed to sit in that seat comes in and is like, and I just love to sit back and watch the interaction of confusion. It's really interesting to me. It's a little hilarious. It's funny. It's a little weird. It's all these different combinations of thoughts occur. So humans are very, very unique in that sense. Very unique. Here's another one. Okay, high schoolers. When we used to have a lot of people in high schools and stuff, and you go into the cafeteria area, it's the same thing. It's so the same. It's just the same. It's almost like prison. It's the same over and over and over and over again. The same little group with the same little people all the time. Very few times you have a person who mingles and runs around and hangs out. So humans, and I bring humans into this topic because we always tend to leave it out. We tend to leave it out. So I just wanted to bring that in terms of distribution. People's work, they go to work, they get up, they do certain things, they brush their teeth, they do certain stuff, they get dressed, and they walk out of their homes at approximately the same time, and they come back approximately at the same time, like clockwork. That's a good thing to have a schedule, but if it's too predictable in today's unfortunate times, that may not be a good thing. Won't go into the details. So we have patterns. So let's take a look at this one. This is a 2013 wolf territories and the kill zone. So you can look at their territories here, right? Now, what makes this distribution different is that, look at this, individual wolves cluster together in packs, making them easier to spot, track, and count. Yeah, because they are like, somebody even said the word pack. I think it was Virginia, don't quote me. Mooses are largely solitary creatures. They're by themselves. They're riding solo. Very rarely are they like in a pack. Very rarely. Now, a mom may have her young, and that's different. What's really interesting about them is that, and they're distributed more randomly, like there's no rhyme or reason why they're going here, why they're going there. It is maybe just food. So counting them requires a strategy. So it's just a very, very interesting things. Now look at what's going on here. Look at the tracking. This is an aerial view of plot number 87. Don't worry about the numbers and stuff. Outlined in orange, the green dotted line defines the 9 overlapping circles flown as mooses are counted. They're just, this zigzag. There is no real pattern going on here. Now these over here, they're more defined in their movements. Wolves have more of a defined, these are just more randomly moving around. These are a little more calculated. And not only that, but when they move around, they have to be thinking about the other packs and trying to respect their territories. A moose doesn't think like that. A moose is like, I'm just rolling around. Very different distributions of in terms of movement. So hunting a moose, let's say you're out there, you're trying to survive. You're out there somewhere, let's say Alaska, and you're trying to hunt a moose, and you're just like perched up somewhere. Good luck. Good luck waiting for a moose to just waltz in, because it's sporadic, right? sporadic. Now you follow a trail and you're really hungry and you want to eat a wolf out there or some other animal like a deer. Hey, now you're talking. Now you can follow the trails. You can look at some of the droppings. You can kind of see more or less when this animal was around, and they have way more routines than a moose would. So I would not try to be shooting or take down a moose if I have a firearm and I'm hungry, because I know that they are very random in their movements. I rather eat a wolf because I can kind of follow their trails. So let's talk a little bit about distribution patterns, right? We're kind of on the same topic of what we were saying. So random distribution may allow individuals to maximize their access to resources. So yeah, if you're going to be moving out and about, you're going to be more, you can get some more resources. This is a great picture. And we look at this picture, again, pictures are important. We look at this picture and we see, oh my God, all these beautiful, beautiful different colors of trees. We don't get to see that here. We don't have that, right? We do not have that here. We sometimes struggle in our seasons, but we got a real good surprise this winter, didn't we? Individuals are equally likely to be anywhere within the area. So they're random. Like, where are they? They kind of say equally, and it doesn't. They're like, what do you mean equally likely? They mean the probability. And what is the probability of this type of tree being over here? Well, it's the same type of probability of that tree being over there, or over here, or over here. It's distributed. It's distributed for multiple reasons. It could be birds spreading seeds and they're flying in different directions. It could be animals consuming and animals are moving maybe in different directions, and they're goes to the gut and it drops the seeds and trees grow. Or it could be you got other insects coming over and pollinating, and you got others a wind dispersal of seeds. It could have been a fire so many things can happen. So many things. So we talked about clumped. Now, in this particular area, like this school of fish, these are high density clumps and well, there is a reason for this, right? They stick together. This is an evolutionary advantage for them. So versus the solo little dummy head who's out there in the deep, it's going to get eaten. This is a huge target. But here they all move as a pack. And if a fish comes in here to try to get them, like they all kind of move away in different directions. So it increases the likelihood of survival. But if you're the lone fish out there, little brave little fish, it's, like Nemo, you could be eaten. Now here's something that's really interesting. Penguins. Look at that distribution compared to this one and compared to this one. This distribution or map population distribution is so like it's almost like it's like a COVID CDC, fantasy. Look at the 6 feet apart all around so equally, like, wow, it's just so nicely dispersed. Well, there's reason for that. These penguins need to give themselves a certain type of space in order for them to have their young, their mates, all the things that they do. They need that distribution. It doesn't work if they're too far apart. It doesn't work if they're too close. And this is what is ideal for them. And it is fairly uniform. It really is. Well, it doesn't give a lot, but this is just uniform distribution results in a territorial behavior. Yes, it's a behavior, but there are advantages for them doing that. They wouldn't be doing it if there wasn't advantages. So all of these, uniform, clumped, random, they all have their individual advantages that help them ultimately reproduce. So let's take a look at a growth rate. Population, we're in population growth topic, a growth rate. A growth rate, difference between the birth rate and the death rate. So you're going to do a difference. You get the math and you do the difference between the birth rate and the death rate, and you have the growth rate, right? What is What are some of the factors that influence this growth rate? Well, you could also have immigration, right? You could have a birth rate of a particular location, but then you have an influx of immigration. So you have an influx of individuals into the population, that's the young population. Yeah, that's going to affect that growth rate, because you got to still get those those that are migrating or immigrants into the population. You got to count them. If they're the same species, you've got to count them. So yeah, it's going to affect growth rate. Then you have e-migration, so movement of individuals out of the area, out of the area. That's going to affect the growth rate. Let's say you have a population of humans. I can think of a state right now in my mind, won't say it, that I mean, millions are leaving the state and they're coming to Texas and they're going to Florida. That's a fact. That's going to affect their growth rate. And let me tell you, it's going to affect more than their growth rate. It's going to affect the tax revenues, how much taxes they can get, and so forth and so forth and so forth. Just as I've told you before, the balance. And there is never a perfect, there's always, it's oscillating, it's always functioning. And the decisions humans make, whether they're policies, whether they're environmental, all that impacts people, will always impact people. And people will always react to them. They may not all react the same, but they will be reactions, and there will be consequences. And those consequences will be positive, and some of them will be negative, right? So we are not so different. Humans will move to other places that better suit them for their jobs, for which jobs provide us food. And so we move for food, and we move for luxury, and we move for comfort, and we move for safety. Not all of us want to live in a very dangerous neighborhood. I don't. Do any of you want to live in a dangerous neighborhood? No one says anything, so I'm going to say no, right? We're not that different. We're not that different. So we move as well. Or Laura, I saw you light up. Did you want to say something?
No, I just wanted to answer you. No, I wouldn't want
Oh,
to
no,
live in a
thank you.
dangerous neighborhood.
Thank you for not wanting to live in a dangerous environment. I don't think we want that. Well, I don't think we want that for our children. We don't want that for our loved ones, our little brothers, our sisters, our nephews, our nieces, all that. So we move as humans too. We move to different places, maybe places that tax us less. So when we study this, and we look at animals, I want you to not be the common person who always removes the human out of it. No, 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 don't do that. I want you to insert yourself in there, because you are part of that ecosystem. And if anything, you and I play a major role in the ecosystem. What we do and what we don't do can have serious results on our ecosystem, right? So we need to insert ourselves in there. We need to be, I would love to see a biology book change the thought process and put humans in there and look, hey, how this works. Humans do good things too. When certain disasters happen, and or maybe certain things get burned, they go and they plant trees, and humans do good things. It's not all bad. There are a lot of organizations or NGO, non-governmental organizations, that try to promote clean waters and streams, and they get little turtles and stuff, and they try to get them a little bigger, and then they release them into the oceans, or they help them get into the ocean on their long little journeys. Like, humans are not all bad, but we do harm as well. So we need to insert ourselves into the conversation of ecosystem more often. And that is what I am trying to do. That's why I'm trying to bring us into this, to show us that we do have behaviors. We do have certain things that we do that may not be like a moose, it may not be like a wolf, but we have certain patterns as well. Let's look into types of population growth, exponential growth. That's probably something maybe you've looked into your math class, exponents or exponential. So this is an unrestricted growth of your population increasing at a constant growth rate. That means it's really increasing, you know. Bacteria are a really good in organism to show exponential growth. Logistic growth. A logistic growth, it's going to start off fast and then it's going to kind of level out. Why would it level out? Well, it's probably related to some sort of environmental conditions. It could be weather, then that affects grass or trees, some sort of food supply, and then that group of organisms is not reproducing at that such a high rate. So environmental factors, and that's what they're trying to say here. I just added more to it. One could be, let's say, here's an example of logistic, right, of starting off fast and levels off. It says access to the habitat. For example, the physical environment where organism lives and to which it is adapted. Okay, yeah. But let's just say there was a large, I'll give you a better one of this one, fast and then levels off. There was a beautiful forest somewhere, beautiful forest. And it's been there for hundreds and hundreds and hundreds, thousands of years. Nice forest. And you had some people go camping there and they decided to do a little fire and then they decided to kind of like, okay, move off, but they really didn't put the fire out. So I'll really do a good job putting, they didn't kind of throw some dirt over it or something like that. And then a wind came and the wind came and kind of threw off and started or throw off the ash. And then you had some coals and they started lighting up a little more. Some of you who've been around a fire know what I'm talking about. And it started lighting up a little more. And then maybe a stronger wind came and maybe some little ashes or embers went and then there was grass around and it started a fire. And it spread. And there were a bunch of squirrels there. And they were very happy. And this fire, like pretty much burned everything. Well, yeah, the little squirrels moved somewhere, those that could get out of the path of the fire, or those that died that went up the tree that thought they can save themselves, burned. So that population was like this. Well, now it's actually kind of gonna level off and most likely gonna go like this. So that's a very likely possibility, right? So I'm just giving you examples of what could occur. Carrying capacity. This is a very, very, very interesting concept. Carrying capacity, the maximum number of individuals that an environment can support given its space and its resources. The upper limit on the size of any population, right? We'll come back to the carrying capacity. We're going to take a look at some of these exponential growth, logistic growth. Here we go. This is an exponential growth. Usually bacteria do this type of growth up like that. Here showing this, I wish there was like in blue and red, not this faint color, in case we have students that have a color vision and the rods and the cones and the behind the eye aren't functioning like at optimum conditions and they kind of can't distinguish the colors. So I'm just going to say the one with the little up and down, that's the logistic growth, okay? And then they put this thing here called the carrying capacity. The carrying capacity is up here like, wow, like once you pass this part here, you might run out of resources. And once you come up here, you might run out of resources. So it's very interesting that this line kept going up. Very interesting that it just kept going. Exponential growth will only keep going until unless you have unlimited resources, like it says over here, I think. Yeah, unrestricted growth, population increase. Oh no, it doesn't. Trust me, I'm telling you. You gotta trust me that the only way this happens is the population must have some sort of nutrients and food. And if the carrying capacity is here, it typically would not continue going. It would eventually come back down and go below this a little bit. You want an example? I'll give you an example. You get Streptococcus aureus, put it in a petri dish, get a media, so you feed it, and you only put it within that dish and you grow it. Well, it's gonna grow. It's gonna go like this, like it's gonna go nice, exponential growth, super fast up there. And then eventually the bacteria are gonna utilize all the nutrients in that plate. Are the bacteria going to continually grow? No, they're going to start decreasing because they've reached their carrying capacity. So I find that very interesting that it goes up like that. Sorry, I just can't help myself. Let's talk about this carrying capacity. Carrying capacity is a very interesting concept, specifically in terms of the human population. Very interesting. Just interesting stuff. What is the human carrying capacity? I don't know. I don't know. Some say that we've reached it already. We've surpassed it. Some say we are approaching it. Some say that when approaching the carrying capacity, there will be a balance. Nature will find a way to balance it out. I don't know. Maybe, maybe not. I don't know. I cannot tell you. I cannot say that I have the answer to any of those three scenarios. Cannot say that. What I can say is the human population is increasing. That's fact. Why? Now let's talk about that. I'm going to open it up to you. And just like we were talking about animals and what are some factors for them to grow and how they're related, what are some of the factors that is increasing human population growth? Go for it. Because that we know, that I can answer. Yes, we're, as a planet, we're increasing in the human species. Why? All right, I'm going to do a quick roll call. John, are you there?
Yes, sir.
Virginia, are you there?
I'm here.
Fabrizio?
Yeah, don't worry.
Laura?
Here.
Frank?
Here.
Anna?
Here.
Carlos?
Here, sir.
All right. Um, Crescencio. Sorry, I have difficult pronouncing that.
I'm here.
Okay. Gabriela.
Here.
Okay. Yanel. So Yanel, are you there? What are some factors that are going to have increased human population growth?
More babies.
Yeah, I was gonna say reproduction.
Okay, but what? Yeah, we know that because
Are we? Sorry, are we reproducing more than we are dying?
Correct. That's how come we have a higher growth rate. But what are the factors? Like we know that more babies are being born because
Oh, would
that's
be like migration.
okay.
With that, I don't know.
No, because we're not migrating to another planet or coming in from another planet. I mean, on Earth as a species.
Oh, okay.
I think it's because we have a lot more knowledge on how to stay alive. Like we know like what foods we should eat, what medicines we should take, and then like how we get vaccinated for certain things that could be deadly like back then. And like aren't now because of the medicine that we have and the technology we have.
You're 100% correct. 100% correct. I think she practically almost hit all the points in terms of the human species. I think the only thing maybe I couldn't quite hear people were talking agriculture in technology. Well, she said technology, so she's kind of in the ball game there. But man, I think she hit it out of the park. Those are the reasons why it's not that we're having more babies or migrating in, migrating out. I mean, on planet Earth, something had to change, and our ways of life, something had to change, and medicine, technologies, vaccines, millions upon millions of lives have been saved through vaccines. That has been an amazing thing. She mentioned medicine, so this is another one in there. Antibiotics. Wow. That's just wow. Amazing. So we have these new things, and that's a reason why we are growing as a population. And if you really want to see population growth, you really want to see it, drive from, if you can see some aerial maps, look at some aerial maps of 10 years ago from San Antonio I-35 all the way to the end of Texas and 35. And if you could look at an aerial map of those two different time frames, you would see a drastic change, an expansion beyond belief. You cannot almost tell. There used to be a time when one could drive from San Antonio to San Marcos, and there was like a large gap of there would be like a farmland and even some maybe brush land along the way. Now you don't know which town you're entering in unless you're really keeping track. It's upon town, upon town, upon town. It's almost like why it's called the I-35 corridor. It's just a bunch of cities, and it's just the expansion. Those houses have people living in them. They're humans in there, and the growth is just going. That's just one example to see population. Now, other places have major growths too. Other cities, other countries, major growths. So again, what Laura said was right on point. And I hope you guys really think about that one, because that is what keeps you alive. That is what keeps me alive. I've had an infection before, throat infection. Oh, I had strep one time. Oh, that was horrible. I took antibiotics, right? I had an ear infection once when I was in the 3rd grade. I took an antibiotics. So can you imagine if I didn't have antibiotics, what would have happened to my throat? And then my tonsils were infected. What would have happened? What would have happened to my ear? The infection could have spread, especially if it's in the head area. It's kind of important, right? So very well done. Very well done. In terms of animals, it's a little easier to look at the carrying capacities. It's a little easier, right? But in terms of humans, that one's a tough one because humans will do certain things to keep moving that carrying capacity up, right? Humans will then just take more land so they can live and then maybe just farm more. You know, let's cut more trees, let's farm more. So that carrying capacity in terms of humans, I don't know the answer. And I'm going to say something I honestly don't believe many people do. I think there's great work and stuff on that, but I don't think we truly fully understand that because it's the planet. And that's a very complex thing to include every individual and our needs. It's a very, I would love to see a really cool mathematical distributional model of this. And wow, it would be a sight to see something of that magnitude done. It would be super cool. So carrying capacity is an important thing. Now we see carrying capacities and how take place in a smaller microcosm like schools, classrooms, right? There's only so many individuals you can put in a classroom, and sometimes they push the bounds of that, and it doesn't result well, right? In terms of teaching and trying to provide the time for individuals' needs and things like that, it just gets difficult. So carrying capacity within schools has its impact, has impact. So we know that if we're farther from the carrying capacity in the classroom, hey, students going to get a little more attention, they're going to have a little more resources, and they can have maybe better quality education. But when we increase the carrying capacity in a classroom, that can be difficult, and there can be a lot of challenges. Again, trying to throw in another example besides ecosystems. Like, look, we encounter carrying capacities in multiple ways. Now, let's take a look at some of the population growth. So the population growth may fluctuate around environmental factors, which then could impact the carrying capacity. Disease, that one we're not immune to. I think we understand that now. That now, Laura said the word technologies, that's a good thing. We're increasing, right? It's a good thing we stay alive. But hey, we are reaching a point of understanding certain things in the field of sciences that with COVID-19, hey, come on, like that's just that's just a it's crazy, you know? So there's some very dangerous stuff out there, ladies and gentlemen, very dangerous. And we were very fortunate that this thing wasn't that dangerous, but there's some stuff that could really hurt the human population. And I mean, that's not to say that individuals that have been sick or died from this, that's not to take away from their pain and from their families. I mean, my condolences go out. My heart goes out. I know people on my side who've died from it, and they shouldn't have. We're all going to die, but none of us should have died from COVID-19. I can tell you that much, and I think all of you would agree with that. I think a pop-up of a raise a hand came up while I'm here. Let me check it out. Do a stop share. I saw a hand.
Oh, that was me, Mr. Delgado.
Oh,
I'm sorry.
Go ahead. Go ahead.
Oh, it was an accident. I'm sorry.
Trust me, it's not a big deal. That's okay.
All right, thank you.
Yep. All right. So yeah, we're not immune to this thing now. We're not immune to that. We know that. There are some diseases we do really well and we fight against. Laura said some vaccines, we could do a really good job, stuff like that. Hey, let's take a look at this one here, right? Food shortages. We as human species, we saw how we reacted in two scenarios already. When COVID came out, we saw what people did. Literally, did any of you did any of you see, what did you see in terms of food shortages? What did some of you see when COVID came out? in terms of food shortages? Did any of you see some of the aisles lacking food?
It was empty.
Empty. Did anybody else other than John see shelves with no food?
Yes.
Yeah. And how did that make you feel?
Worried.
Disappointed.
Disappointed, worried, uncertainty. But notice how the human species, when compared to um, deer and other species, they just kept on moving along, right? Like it was another day for them, just another day. But we're very dependent upon transportation. We're very dependent upon fossil fuels, gasoline, diesel, specifically diesel, to get product from one place to another. We're dependent upon tractors that are going to farm. And I think we've done a real good job in this class showing you all the things it takes to get food to the shelf. Again, most Americans don't understand all the different paths it takes. You as biological students, you are now learning, wow, there are a lot of steps in this system. And this system is very fragile. And we can see how certain events can impact our food supplies. And that is also worrisome, right? That can be worrisome. However, in terms of other species other than us, their food shortages are highly dependent upon it starts with plants and trees. If certain plants and trees that herbivores eat, if they're good and there's good shortages, there's going to be good populations of that particular organism, which will then be eaten by some other carnivore, right? And that's the food web. Okay, we don't really have that. We humans, like, they're very, unless you're out in the in somewhere where there's large animals that could eat you, like, you're really not at risk. So I would say like 99.9% of humans are not at risk of being eaten. Like, you don't wake up in the morning saying, oh my gosh, am I going to be eaten today? You don't worry about those things. You have other worries, but that is not one of them. So I want to just show you that disease. Now, animals, in the case where Laura said, like, we have some defenses against disease. It's true. Not all, some. But animals, though, like, if there's not human intervention, they're gonna die. So disease has in the wild, in nature, diseases that do occur that are not human made, that are natural diseases, natural, they do affect populations. They do. And it could have some serious effects. And then it affects one species, and then due to the food web, it affects other species. Allows the environment time to recover its food supply. That could be another thing that has to happen, that with the example I gave you of the fire in the forest, it is time. Within time, it can recover, but there will be an impact to the population and the ecosystem within it, and then the population can grow. Once that food supply is then comes back, boom, you have a boom and a burst. Like, it just keeps on going. Like, now it's going to increase. So those things happen. Now, if we take a look, and we'll be ending it with this one right here. We'll end it with this last slide, because we'll hit your 11:20. Well, we're a little bit over. Sorry. We'll end it with this slide. So we take a quick look here, and what we see with wolves and moose is that the wolf and moose population are intimately linked and inversely proportional. When wolves populations are high, the moose population is low. So when this is high, look how it goes low, because they try to attack. When the wolf populations are low, the moose population goes high. So you see this down here. Look at this here. The wolf population decrease. It could have been disease. It could have been environmental, something happening, but it brought down that population, and look, that went up. Look at the consequences. Again, when I say consequence, that doesn't mean it's a bad thing. It's not like you will suffer the consequences. It's the result. This is a result. This is nature happening. This is not, as humans have nothing to do with this one, this graph. So we see this inverse relationship, meaning the opposite happening here. So we're all connected. You know, all life is connected one way or another. They're connected. They're connected sometimes in ways that we don't understand, right? There's so much, specifically in ocean and rainforest, interactions of species. How can we even understand the interaction of species if we don't even know the existence of certain species still on planet Earth? There are still species we don't know. How interesting is that? And how cool and crazy is that? That there's life on Earth that we don't know about. That just blows my mind away. Like right now, as we are in this lecture class, there are species on Earth, like our planet, that we don't even know about. Like, that's alien, right? The unknown, not knowing. How cool. So hopefully with time, we get to understand more and more species and understand interactions with one another, including the human species, so we can try to live in this harmony, so we can coexist amongst each other within our species, human to human, human to other animals. And that's what we need, so we can continue living on this earth. We need to cohabitate with one another. And the more that we understand the impacts, the consequences, the results of certain events, the better we can manage that and not have drastic shifts to one side or the other. So all life has a right to live. All life has a place, you know? So I hope this, again, this lecture teaches you that on planet Earth, we are a highly integrated planet with lots of different life, and we are somehow, some way connected to all of it, and we all play a little role in it. So, ladies and gentlemen, thank you for that. I just did the roll calls. I just wanted to see if we had who was really attending, and I'm gonna give you some bonus points for attending there. Do we have any questions before you guys head out?
Bye.
Bye-bye. Take care.
Bye, doctor.
Thank
Have
you,
a good
sir.
day.
See ya. Take care. Bye-bye.
Goodbye, sir. Stay safe. Have a good day.
You too. Take care.
Dr. Delgado.
Yes.